Let's start working on JiFluid library. Hello everyone, this is Ali Reza. Welcome to the Mentor Code Lab. We finished our JInventory. Compared to JInventory, the Fluid system is almost identical with a little bit of change, and we should be able to proceed faster. Again, the solution will be a combination of my code and what Turti had. Hopefully, I can make it work faster than what we had for JInventory with less hiccup. The first step is to add our build.gradle to the library. We can just right click on it and say link Gradle project. Of course, it will try to sync the library, and not only that, it now tries to sync everything for me. So I will have to stop the video and come back when it's done. Now, as the project is syncing, actually, we can use our time to remind ourselves what did we have in the JInventory, because we may drop some things and other things will remain. In the base, we have this connector. We will use that. We don't have a private key anymore. We have a block entity that is dedicated for any block that has only a fluid container. We will not have anything in the client. We will have some interfaces. We will have inventories. Although now that I think about it, it would be better to change the name from inventories to be storage, because inventory means that something that has slots and item stacks in it, and fluids are just storages. Anyway, I will maybe fix that name for JInventory between the episodes, but we will have sort of a storage classes that we need to implement. For records, we have this predicate inventory storage, and if you take a look at that, it is actually an inventory storage and two Boolean suppliers. We will have something like that for the fluid again. We won't have any screen because fluids are using widgets in my system, and we don't have any special screen for that. And we won't have any slots here. I may add one slot, and that is fluid container, because writing it over and over all the time is tiresome. Because, for example, we may want a slot that has a fluid bucket, for example, or any water bucket. And using the combination of a predicate fluid container with a fluid slot, fluid container slot, will make us happy later on when we are designing our library. Anyway, the importing is finished and we see the JiFluid on top. The first order of business is to generate the packages to make our life easier. And as I said, you will see that I will go back and forth between the JInventory and JiFluid a lot, because most of the time they are identical. We will have a base, we will have a block entity. We won't have the client side, because remember that is returning a client-sided inventory. We don't need that. We want the storage. As I said, the name will be changed on the JInventory. We will have records or record, I don't know. We won't have the screen, but we will have one, maybe one slot, okay? No, not the class, goddammit. Here, a packet. Now, to begin with, the easiest place to start is actually the inventories, because when we have the inventories, we know what we are working with. So if we take a look at Turtiworty's repository, for the fluid, he has this synced or syncing fluid storage, a predicate fluid storage, and output fluid storage. Output fluid storage is just a predicate fluid storage that cannot insert, but it can extract. The predicate fluid storage, again, predicate for insertion, a predicate for extraction. And you see that here he moved away from being a record, because in our library for predicate inventories, we are using a by predicate of item stack and integer, and our record is for inventory storage that handles insertion and extraction. It's totally different from what we have in the fluids. So in fluids, we will not have that record. It's more like the predicate inventory. Then he has the output and input. Fluid stack we already covered in the base, so we don't need that. And then he has this wrapped fluid storage. In our case, it will be the fluid connector. So let's start with the synced one, and let's remind ourselves what do we have here. We will implement isync, and then we have the block entity and is dirty. However, in case of fluid, we need to have the capacity too. Then we have this constructor that needs items. Well, guess what? Here we don't have any of them. We just have the capacity here as a long. Then we have the sync method, but because we are using fluids, we will add more things like on final commit, and then we have the mark dirty and get block entity, of course. Then we have more methods for can insert and can extract. So let's start by adding our synced fluid storage. And as I said, it should implement isync from our library on GBase. Then we will have the private final block entity, and we call it block entity. Then we have a private final long, that is our capacity. Then we have a boolean that is private and is dirty equals to false by default, a constructor. And as I said, this time we will not accept items, so I just hit alt insert constructor. We want the block entity and the capacity and nothing more. Of course, we need to override the sync method. Oh, sorry, it's not isync, and here I need to be careful. I think, yeah, it's isyncable. Okay, now it is yelling at me that I need to override a method for the sync, and that is exactly what I wanted. Then we will have on final commit, and we need to be protected void. Then we will have a public boolean can insert that accepts a fluid variant of variant, and public boolean can extract the fluid variant. Those are self-explanatory. We will check if it can insert or extract any type of fluid. Then we want another overload for these, and that is to accept fluid stack instead of variant. Okay, because if we have it, why shouldn't we use it? Fluid stack payload and fluid stack payload. Although remember, it's more like not being used as a payload, but I did add the codec and packet codec so that you can use it as a payload if you need to. After that, finally, we need that mark dirty that we need to use, and that is a public void. All we will do is say this dot is dirty equals to true. That's the easiest one. And finally, I need get block entity that returns the block entity. I need to add something else, and that is get capacity. So we will have a protected long get capacity, and this one will accept a fluid variant called variant, and that should be it. However, I need to extend this class from something, because remember, we are a fluid storage, so we extend from single fluid storage, and because of that, I think the single fluid storage is providing the read NBT and write NBT for us, but nothing else. It is extending this guy, so let's take a look. The get capacity is an extension. The can insert and can extract are extensions, so let's add that override marker on top of them. So get capacity is an override, the can insert, can extract, and I think the on final commit should be override. Yes, these are not overrides, they are what we are adding there, and we don't need to handle anything else there. Now get capacity, let's start with the easy ones. We return this dot capacity, that's simple enough. On final commit, we will do two things. First, we call the super dot on final commit so that the higher up classes do whatever they need to, and then we say this dot is dirty equals to true, so we sync at the end of the tick. For this sync, let's take a look. I want to handle the easier ones first. Okay, the can insert is actually easy. We can say return super dot can insert the variant, return super dot can extract the variant. In these two cases, we return something, and we check if this dot variant equals to the fluid stack that we sent in. I will need to change these guys to fluid stack dot variant, or what did I call it, fluid, or this dot variant dot is blank, means that we don't have any fluid right now. We return this, and fluid stack dot amount is less than or equals to this dot capacity minus this dot amount, means that the stack can be inserted into the fluid container, because if we are full, or let's say like this, let's say that the capacity is 10,000 millibuckets and we have 9,500 millibuckets. It means that we can only accept half a bucket worth of fluid. However, if I want to put a bucket there, it should not accept it. So this is that bucket. What we are saying that, hey, if that 10,000 minus the amount that we have, that is 9,500, the result will be 500. Can we be smaller than that or equal to that? In this case, 1,000 is not a smaller or equal to 500, it will fail. But if the result of this calculation would be 1,500 and we want to send in 500, yes, 500 is smaller or equal to 1,500, so yes, we can insert. Okay, that's the calculation there. For can extract, we want to make sure that we still check the variant, so we return. The variant is the same, and fluid stack amount is less than this dot amount. We don't need the capacity there. This time, if we have 500 millibuckets of water and we want to extract 1000, we should fail. But if we have 1500, yes, we can take 500 out of it. Okay, these were finished. Now let's go into the sync method. Let's take a look at that synced inventory and see what we are doing. Here we say if this dot dirty and block entity is not null and it has a word and the word is not client, then is dirty equals false, and then we update the block entity. Okay, now I did need to change this a little bit because I'm not sure. Here we are assuming that our block entity is actually updatable. What if someone tries to insert this inventory inside the vanilla block entity? For example, he's not happy with how we are doing our update stuff and he wants a pure block entity, but he's happy with using the synced inventory. This will fail. I need to adjust my J inventory and say if this dot block entity instance of G block entity, then please update. Else simply say this dot block entity dot mark dirty. If we compare this to what we need to do inside the synced fluid, they are exactly identical. We don't need to do anything else. And let's close this. I need to suppress that warning here because it says that it can be null, but get world is already checked at null. So it's just the stupidness of IntelliJ. Now, why are you not happy? Oh, I need to name this guy BE. And here we say BE.update. And why are you not happy? Because I think it has raw usage. Yes. So it will be of any. And I need to fix that one there too. And it will be BE. Okay, here we go. This is why I need a block entity here. And then here I will accept the block entity. Okay, this is getting ugly really fast because in our library we may want to use something that needs to access the methods inside the G block entity. So I will add public that returns a G block entity of any, and that is get GBE or block entity. Why not? And here I will do this check, and instead of this I will say if we are BE then return the BE, otherwise return null. And now I need to mark it as nullable, and I will add this here. I'm opening the door to null point exceptions in my mod or anywhere else that I will use these, especially another error that we are accepting a block entity and handling things differently there, but I will fix it in my main mod if I need to when the time comes. Anyway, now that we have that out of our system, let's double check everything. We are syncing, we are getting the capacity, we are doing the final commit, we are doing can insert, can extract, mark dirty, get block entity, and the G block entity. Okay, I think we are done with this class, believe it or not. Let's go to the next one, and that is a predicate fluid storage. New Java class, predicate fluid storage. Now, predicate fluid storage is simply extending our synced fluid storage, and we need to create constructor. However, after the capacity, we will accept a predicate of fluid variant, and we call it can insert, and one for can extract. Because of that, we need to have two fields. I'm not sure if we can have anything. Yes, thank you. Can insert, because ReSharper has this ability that you can add things to your constructor. Hitting Alt Enter, it says create field for parameter. Not only it creates the field, at the same time, it will handle the assignment. I'm happy enough. And then we need to override the can insert for the fluid variant. Here instead, we will say this dot can insert dot test on the variant, and then can extract for the variant. Again, we will say this dot can extract dot test on the variant. I am thinking, can we do an overload for the fluid stack? Unfortunately, I think not, because fluid stack has that amount thing, and if we want to cover that, we need to handle that inside the predicate itself for can insert and can extract. So this is all we can do here. Now we will have output fluid storage. This will extend from predicate fluid storage. And yes, we will add the constructor. However, because this is output, we are not inserting anything. So we can simply say that the predicate here, we are not even extracting anything. So we have this, and simply we say that can insert should be false. So we put a dollar here because we are not going to use anything there. We send out false, and here we will send out true. Now I will have another overload for this that will accept a predicate of fluid for the extract. So this is can extract, and here I will say just send the can extract instead of that default true. But the insertion is always false. The reverse will happen on the insert fluid storage. So this is input fluid storage. This is again extending the predicate fluid storage. And I will create the constructor. I will copy it. I will paste it here. We don't have that predicate. And here we have no predicate. So for can insert, we go with anonymous lambda of true, anonym lambda of false, and again this time anonym lambda of false. And that's our storages. Now I will stop the video here. In the next video we will come back and work on our connector. If you like these videos, please subscribe to the channel, hit the like button and turn on that bell so that when I publish a new video you will get informed. Have fun everyone. Bye.